So we want to now talk about moment of a force about a point using cross product. So you've already seen that if you want to find moment of a force F, let's say about point O, you could do this by simply using the definition of moment, which is F times D. Remember, you have the line of action of this force like that, and then D would be the shortest distance from the point to the line of action of the force. So moment is simply F times D, this moment about point O. So the magnitude of the moment is F times D, and remember the direction, the direction of the moment is the rotation that this force generates about the point. But now what if you wanted to do this vectorially, meaning using cross product? So usually the F times D is used for two-dimensional problem when the force and the point are in the same plane. And for three-dimensional problems, it's much easier, it makes more sense to use the cross product. So let me go ahead and show you how this is done. And I'll prove it to you that actually the magnitude is going to be F times D. So let me just erase this and also this one. So we start fresh. So let's say you have your force, F, and you have your point O. And you want to find the moment of this force about point O. And you want to do it vectorially using cross product. So that becomes actually is equal to this moment is R cross F. So what is R? R is called a position vector. And remember, the cross product, the order is important. So R comes first and F second. Position vector R is defined as a vector that goes from the point to anywhere along the line of action of the force. So you see the red line is the line of action of the force. So I have the flexibility to go from O to anywhere along the line of action of the force. So I'll just say it there. So that's position vector R. So you do the cross product and that's the moment. But now let me prove to you that this magnitude of this moment is actually F times D. So that you see the magnitude happens to be the same magnitude that we had before, F times D. So you guys recall that the magnitude of the cross product, right? The magnitude here, this, is what? How do we determine the magnitude? Is the length of the first vector, which is R without the arrow, times the length of the second vector, which is F, times the sine of the angle between the two vectors. So we are referring to this angle here, theta, which is the same one as here, theta. Okay? So, what if I actually did this? What if I rewrote this as F times R times sine theta? And I haven't done anything wrong, I just rearranged this. But now take a look at this. R sine theta actually is D. If you look at this carefully, R sine theta happens to be this shortest distance that we talked at the beginning of this video. So remember, R is the hypotenuse in this triangle here, right? And D happens to be the opposite to that angle. So I just proved to you that the magnitude of this moment, magnitude, is F times D, which is the way it should be. So remember, usually for two-dimensional problems, we just use F times D if you could find that perpendicular distance. If not, if you have a three-dimensional problem, use R cross F.